Hello everyone, welcome back to our series of lectures, and we are covering the course Business Statistics, and today we are going to cover about the descriptive statistics, and we will move deep down into descriptive statistics where we will be discussing the central tendency, and then we will be talking about variability and other things which are important from descriptive statistics point of view. So actually whenever we are talking about central tendency, we are talking about the mid values, because statistics is most of the time dealing with the averages. It is actually, especially the inferential statistics, is providing a solution of the things which we cannot cover it because of paucity of time. And how it is providing us a solution? Through the sample, study of sample. We are studying the sample and we are generalizing the result. So that becomes important only when we are having a proper understanding of descriptive statistics, and then we are taking the things out of description and applying those for a population through the study of sample. That is a part of inferential statistics. So let us start with our journey. So the thing which I am going to discuss today is central tendency, which is one of the most foundational idea of statistics. It helps us to understand how one value can represent the entire data set in a meaningful way. In statistics, we often collect many observations, but if we want to interpret them quickly, compare groups, or make decisions, we usually need a single representative number. And that is where central tendency become important or useful. In today's lecture, we will understand what central tendency means, study its three main measures, mean, median and mode, and learn when each one of them can be used, where each one of it is useful. By the end of the lecture, you should not only know the definition, the meaning, but also you will be able to choose the correct measure depending on the nature of the data. That is especially important for assignments, research work, interpretation of the real world problem. Everywhere you are applying statistics, because most of the time you are working with averages. You cannot read each and every unit of the population, and that is why you are just dealing with the averages. And the first thing which you deal with as an average or a mid value is central tendency. Central tendency, as we have just discussed, it can be segregated into three different forms, like the three different observations. One is like mean, median, and then mode. So let us move ahead. The quest for typical value. Why one number? Let us begin with a simple question. Why do you need one number at all? In real life, data set contain hundreds, thousands and lakhs of values. We are usually talking about big data. So when we are talking about the big data, the observation may run into crores. Therefore, looking at all values separately is possible, but understanding the overall pattern quickly becomes difficult. And sometimes it is also not possible when the data set is too large, too cumbersome. So, statistics give us a practical solution, a representative value or a mid value, mean, median, mode. This value give us quick idea what is typical or central data set, or what is a mid values or mid points. So, we are looking for one value that can represent the entire data set, right. So, that is why central tendency is not just convenient, but necessary sometimes. The payoff is very important. Once we summarize the data properly, we can compare groups, identify trends, and communicate finding more clearly. In another words, summarization converts raw data into useful information. And as we begin with summarization, which we have already discussed in the previous lectures, we will try after we are trying to prepare the summary, and then we are presenting the data through in a graphical form or tabular form, and thereafter moving deep into it data, we will be looking for the descriptive statistics, which we discussed in the very first lecture. And the first thing of descriptive statistics is like central values, and which is where we are starting our mean, median, mode, right. So, what is the payoff? Turning cures into concise, actionable insight that drive decision, comparison, and conclusion. That is what the outcome is. So, what is central tendency? It refers to the statistical measure that identifies a single representative value for the distribution of scores or for distribution of data. In simple words, it tells us where the central of the data lies, or central unit of the data lies, or central value of the data lies. We can think of it as a balance point. If the data set were physical object, central tendency would indicate where it balances. It helps us to reduce complexity and focus on the general pattern instead of getting lost in individual observation. Let us take an example. If we are inquiring from students what your scores are, so the student start telling or narrating the absolute values, 37 out of this in this subject, 67 out of this in this subject, then things will not become clear instantly. It will take time to come to the conclusion. But if I inquired about the student's percentage, I can come to the quick conclusion, this student is of that intellect, or his performance or her performance is at this level. If I ask you and you said, sir, my score is 86, so I can draw a quick conclusion about your performance. That is where these central values are helping us. Single representation is helping us. It helps us to reduce the complexity and focus on a general pattern instead of getting lost in individual observation, as we discussed. This idea is useful in many situations. We are less interested in every single value and more interested in overall tendency of the group. If I'm coming to the class and I want to know the standard of the class, then I would be asking, okay, what is the level of the student whom I am delivering a lecture, and for that I may be told the students are of high intellect, average intellect. All are good, obviously. Okay, what is the average percentage marks of the class. So that actually give me a quick answer, and I can draw a quick conclusion about the class, because I may not be having that much of time that I'll ask the percentage of each and every student, and that actually give me an idea where I have to take my lecture, to what level I have to start with. That is why central tendency is one of the first concept that student learn or should learn in a statistics. The three main measures of central tendency are mean, median, mode. We have already discussed that. Each one tried to describe the center, but each does so in a different way. The mean is arithmetic average, calculated using every values. The median is a positional value or a middle value when the data is arranged in ascending or descending order, and the mode is more frequent values. It focused on repetition of observation of the value or reoccurrence of the value, or I can say the values with higher frequency affects my mode. At first glance, these may seem similar, but they are not interchangeable. Each has its own importance. One of the most important lessons in statistics is that the right measure depends on the type of data and the shape of distribution. And we cannot apply or replace one set of value or representation with other set of value. If let us take an example, generally speaking, mean may be a good representation of data if data is quantitative and continuous. But for qualitative data, usually we are using median, not for all type of estimation or calculations or testing, but for majority of testing, median is doing good, because we are measuring the responses on the scale, and in scales mean is not that relevant, because if I'm say I'm satisfied about something, I'm saying that I'm not satisfied is 1, and I'm satisfied is 2, and I'm highly satisfied is 3. So 3 does not mean thrice of 1. Then median may help us. And if we are dealing something like if we are going for a brand purchase, and if I am intended to buy the shirt or a shoes, then shoes or shirts are not usually made using mean or median. Rather, it uses mode, frequency, so that it fits large population. So each type of measure has its own relevance, and we have to look the need of data where one measure is fitting and where another is fitting or relevant, right? Moving ahead, let us talk about the mean first. Mean is a mathematical gold standard which is most common use of measure of central tendency, usually in finance or business. Mean is considered as one of the preferred version of or preferred measure of central tendency, because most of the time we are dealing with the quantitative data. For a population, the mean is represented by mu, usually written as like this Latin word. or for population, capital letter X bar, and for sample it is like small letter x bar. So, this is a representation, and how we are getting the mean. Obviously, the simple mean can be calculated as summation x divided by n, where n is number of observation in our data set and x is total of those observation. Means we are adding the values and we are getting the total, and that has to be divided by number of observation, which is n. So, calculation of the mean is simple. If I have 5 values, say 20, 15, 10, 25 and 5. So, what I am going to do? I am going to take the total of it. This total, if I say this is x, the total of x is summation x. So, summation x की value क्या होगी? We just need to take the total of it, and this is like say 15, 5, 1 carry, 3, 5, 6, 7. So, it is 75. 75 is my summation x, this value 75, and n is number of observation, the count 1, 2, 3, 4, 5. So, I have 5 observation here. So, what is my mean? 5 by 75, 15 is my mean. So, I can say my mean is 15. Now, whether it is a sample mean or a population mean, the formula may change. There is a little bit change in the formula depending on whether it is sample mean or population mean, right. Usually, summation x by n is a commonly used formula. And then whether we have to represent the mean from this or mu, again depends on whether it is a sample mean or a population mean. So, the formula is simple in an idea, summation x by x, add all observation and divide by the total number of observation. So, mean uses every single value in a data set to add up to the total. That is why it is often considered as mathematically powerful, because mean is a representation of all the mathematical values, and all the mathematical operations can be conducted through the mean. In as we discussed, in a business, mean has its own relevance, own importance. That is why it is often considered as best measure for business data. The reason it is so widely used is that it includes all data points in a calculation, nothing is ignored. Because of that, the mean becomes the basis of many advanced techniques such as testing, such as t-test, z-test, predictive analytics like regression, and other analytics like ANOVA, where we are having more than 2 samples. So, in parametric test, particularly, mean is considered as best measure of central values or representative value. So, when students move to higher statistics, the mean remains relevant and significant. Okay, and we have seen one example also about the mean, but this is a very simple example, basic example. But and further, if we move ahead deep into mean, then we have different type of means, and mean varies from group data to individual data set. For we are using different ways to calculate the mean. So, we will be discussing it in a later part of this lecture. Mean is a balance point. How? Mean is often described as a center of gravity of the data set for its qualities. This is very useful interpretation because it shows that the mean is not just an average by formula, but a balancing value. We have already talked about this. What does that mean? It means that total deviation below the mean is equal to the total deviation above the mean. Mean is a balancing, half of the values are above the mean and half of the values are below the mean. So, we can also say the total deviation from the mean is 0, means positive value and negative value, if we add it up, they cancel down and the total difference from the mean of the entire data set is 0. And this property again plays a very important role. So, the mean balances the entire distribution, but this strength is also a weakness of the mean, because it's cancelling out the differences. Since the mean responds to every value, even one unusual value can shift the entire mean. Outliers effect. I'll take an example. We have discussed in the previous lecture that I want to take the class tour for a trip, tracking trip. So, if say one student want to contribute 1 lakh, others are like ready to contribute 5,000, 10,000, 15,000 and 20,000. So, what I'll see, taking the summation x, the total of this is 1,50,000. 1,50,000, right? And if I want to find out the mean of it, so it is summation x, that is 1,50,000, divided by number of observation, that is 1, 2, 3, 4, 5. Answer is 30. If suppose on the basis of this result, I can say 30 is the best representation of the data set, the best value for the data set, and on the basis of this I determine the package, tracking package for the tour. So, what do you think, how many students out of the total number of student would be able to attend my tour, attend this trip? If this is a sample and I am going to generalize the result on the entire population, I am going to take the decision of on the basis of this sample of 5 students to the entire class or to the entire department students. From here I can conclude 80% student cannot afford this package, and that is what I mean to say when I am saying that even a single value can change your mean. Just one outlier, this is what outlier, extreme value, has changed my mean. It has actually taken it up. It caused my mean to rise above the average of 4, rest of the 4 values, and this is actually a shortcoming of the mean. Since the mean respond to every value, this become a problematic. Outlier become a problem. So, mean is sensitive, and that sensitivity becomes a problem when outliers are present in a data set. That is what I try to explain. Then let us come to the median. We will be discussing mean later on in this lecture, and we will be looking at the calculations related to mean. But let us have a brief idea about all the three type of measures. Then coming to the median. So, median is a positional average, mid on the basis of position. The median is a middle value after the observations have arranged from lower to highest or highest to lowest, ascending or descending way. If the number of observation is odd, the median is exactly a middle value or a middle score. For example, if I have set of data in which first value is 2, 2, 5, 9, 20, 28, 30 and 40. So, what is the median? So, I have arranged the data from lower to higher values or from in ascending order. So, I will calculate the value 1, 2, 3, 4. This is fourth value and this is fifth value and this is sixth value, seventh value. 2, 3, 4. So, 7 values. Which values in the middle? This 3 are positioned above this 20 and 3 are positioned at the lower side of the 20. So, 20 is my median. Right. So, if I am measuring something where position is important, median will be the right choice, especially if I am dealing with the qualitative data. Right, like satisfaction level, happiness level, worry level, medical industry. How you are feeling after taking this medicine? I am feeling okay, better than before. No, it doesn't work. Here, things are not quantitative. Median will work, mean will not work. Right? If the number of observation is even, then there is no single middle number. So, we take the average of two middle values. Suppose in this I add another number which is like 45, which is my 8th number. Then I cannot come to the odd values, like in the earlier example 1, 2, 3, 7 values were there, 1, 2, 3, either this way, and then we have fifth value, then 6, 7, 8, 3 are here this side, 3 are lower side, in the mid 20 was that, which was my fourth value. But in now we have 8th observation. So, what I have to do, take the median, I have to take the middle two values, 3 this side, 3 this side, higher side, 3 are on the lower side, and these are the mid values, middle two values. So, what I am going to do, I am going to add these two values and take the average of it. For example, I will add 20 and 28. right, divided by 2, which is like 48 by 2. It, so 24 is my median, or I can say 4 plus 5, 4.5. In that way also we can take the middle value, but for at we are not having any value at 4.5, right. Okay, the key thing to remember is that median depends on order, not on size of every value. Means median is influenced by the position, and also the data should be in a order, ascending or descending order, lower to higher or higher to lower. Size of the value is not important. Outliers are not going to affect my values very badly as it is doing in the mean case. So, if I have to take the tour again, or the class tour for a tracking, and in that case if I would have used the median, so what was I forgot the value, let it be like it was 5,000, 10,000, 15,000, 20,000, and then 1 lakh. If it differs, pardon me, but what I have done, I have just arranged it from lower to higher or in ascending order. Then I want to take the median value. So, which is my median value? 15, and that is not a very bad choice, because outlier 1 lakh hasn't actually affected by middle choice, mid choice or central value very badly, right. But again, median has its own limitation. So, we will choose later on depending on the type of data, and obviously we have to look at variability also. In statistics, the choices shouldn't be confined or limited to any single set of observation or any single set of measurement. So, to find the median, first arrange the data, identify the central position, and then find the middle values, odd number, simple, the value which is exactly at mid, half of the values are above, half the values are lower side, position wise. And if I have the even number of values, then I have to ignore half above, half lower, and the mid two values are to be added, and then the average of the two can be taken to find out the median. Okay, and the key takeaways like median is not affected by the outliers. Okay, we will be doing more calculation in the coming lecture.